Okay, students, let's start the types of functions which you have already read in your class 11. But once again, we will have a brief preview of that. In types of functions, the first type is a constant function. That is represented by fx equal to constant. Now, what is a constant function? See, constant function means that for every possible value of x that we are providing as input, you always get a fixed output. Say for example, if I write fx is equal to 5, that means whatever be the value of x which we provide as input, you always get 5 as the output. Or if I say fx is equal to say 2 or fx is equal to say minus 3, see, all of them represent constant functions. Now graphically interpreting, see what kind of graph possibly it can represent. See, fx equal to 5 always means a line parallel to the x-axis. Similarly, fx equal to 2 will signify the line y equal to 2, that is like this. And if I talk of fx equal to minus 3, it will form the line y equal to minus 3. So you can very well see whatever be the value of x we are providing as input, you are always getting only one output, that is y equal to 2. Or for this function you are getting y equal to 5. So fx equal to constant is always a line parallel to x-axis. Now few things observations which we can make out from here. The first observation, fx equal to constant is a many-one function. Many-one function, from the name itself you can understand for many values of x you are getting only one value of y. Well, whatever is the value of this constant, that is the value of the function. Now the second part, what we are talking about, is a periodic function. See, what is a periodic function? See, this is also an inherent property of some of the functions. Whenever a function repeats itself after some specific positive interval, then a function is said to be periodic. Now what you can see, there is a kind of repetition occurring. Say, if I call it repeats after say 1 unit, then you can very well see after exactly 1 unit, these sections are being repeated. Now, what is the smallest section after which this repeats? Now, can we identify the smallest section? See, if I say that it repeats after 1, I could have said it repeats after 0.5 as well. But is half the smallest? No. You can find an interval smaller than that also. It can be possibly 1 by 1000. Or if you think of a smaller one, it can be 1 by 10,000. But are we able to write down the smallest positive interval? No. In that case, what will I say? I'll say fx is a periodic function with any positive real number as its period, but fundamental period does not exist. Fundamental period does not exist. So these are two very important things what can be said about fx equal to constant. The second type of function is an identity function. Now, identity function, which function is called an identity function? Fx equal to x. See, this function is named identity function. Now, graphically speaking, if this is your x-axis, this is your y-axis, see this line y equal to x. Now, this is how it will look like on the graph. So, what are the observations that we can draw from this identity function? The first thing, as you can see, if I draw a line parallel to x-axis, it cuts the graph only at one point. So that means one value of x corresponds to one value of y. This value of x gives you this value of y. So this is a 1-1 function. And since there is no repetition of values occurring here, so I'll say that this is a non-periodic function that is also called a periodic. The third kind of function that we get to learn is a polynomial function. Now this is a very important type. Now any function of the format fx equals to a0 x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 and so on till an. Now this, any function of this type is called a polynomial function. Now the question arises, see, what is the degree of this polynomial and what kind of graph these polynomials will form? So let us talk about this. See, n gives the degree of the polynomial. N gives the degree of the polynomial and a0 should never be equal to 0. So if I say degree 1 polynomial, degree 1 polynomial can very well be written of the form ax plus b. Now depending on whether a is positive or negative, generally, see, this is the kind of graph if a is positive and this is the kind of graph if a is negative. So this is essentially a 1-1 function that is called a linear polynomial. And this is how it will look like. But if I talk of a degree 2 polynomial, now any polynomial of the form ax squared plus bx plus c. Now this is also called a quadratic polynomial. Now for a quadratic, see, what are the possible shapes that this graph looks like? See, it can have a shape like this if a is positive, whereas it will have a shape something like this if a is negative. So a quadratic always looks like a parabola, upward or downward depending on whether a is positive or a is negative. Now degree 3. Now degree 3 polynomial fx equals to ax cubed plus bx squared plus cx plus d. Now this is called a cubic polynomial. Now a cubic polynomial can have a shape like this. See, these shapes are just outlines, not necessarily it will be true. So if a is positive, the basic shape is increasing. If a is negative, the basic shape is decreasing. Now degree 4 polynomial fx equals to say ax to the power 4 plus bx cubed plus cx squared plus dx plus d. So this is also called a biquadratic. Now a biquadratic polynomial, see this, what kind of shape does it form? See, if a is positive, generally it forms a W kind of shape. And as you can see, all biquadratic polynomials, that is why in classification I told that they are nothing but into functions, because the range is always a subset of the y-axis. As you can see, this part is the range, the entire y-axis gives the codomain. So the range is always a subset of the codomain, so that is why it is said to be an into function. If A is negative, then generally the kind of shape that a fourth degree polynomial forms is like this. So the basic nature, see, this is what the basic nature will look like. Now, depending on the degree, there will be subtle variations which you have to see depending on the coefficients A, B, C, D, E. Now, the next type of function, that is your fourth type. Now, this is a rational function. Now, what is a rational function? Now, suppose you have, say, any function fx equal to of px by qx, where px and qx are both polynomials, not necessarily of the same degree, then we will say that fx is a rational function. Say, for example, if I write fx is equal to, say, 3x plus 4 by x square plus 5x plus 6. Now, this is what I'll say, it is a rational function. Or if I take another example, say fx is equal to, say, 4x to the power 5 minus x minus 6 divided by 3x plus 7. Now, these are examples of polynomial functions. Now, the next type of function that we get, now from here onwards you have to be more attentive. Now, because from here onwards we are entering a very conceptual part. Now, modulus function. Now, that is also called absolute value function. Absolute value function. Now, what do you understand by absolute value? Absolute value function gives you it is a kind of operator which results in the absolute value of any quantity. Now, it is commonly represented by two parallel lines. Now, just think of one aspect. If you have, say, if I give you minus 3 and I ask you what is its absolute value, now what answer you are going to give me? 3. Now, how do you get 3 from minus 3? See, if I multiply minus 3 with minus 1, you are very likely to get 3. So, what does it mean? Whenever you have a negative quantity, you need to multiply it with minus 1 in order to get the absolute value. But if I ask you what is the absolute value of 5? अगर हम पूछते हैं 5 का absolute value क्या है? 5. यानी जब ये पॉजिटिव है या 0 है, डू यू नीड टू मल्टीप्लाई इट विथ एनीथिंग? क्या हमें किसी से मल्टीप्लाई करने की जरूरत है? नहीं. तो इसका मतलब क्या है? द फंडामेंटल डेफिनेशन ऑफ मॉड्यूलस ऑफ एनी फंक्शन fx. नाउ आई कैन सिंपली से it is minus of that function if the function fx is negative. But I will write it as fx if fx is greater than or equal to 0. So this is the fundamental definition of modulus of a function. So how do you think it? See, you need not think it in a complicated way. बहुत आसान तरीके से सोचना है कि जब भी कोई चीज नेगेटिव है, उसको -1 से मल्टीप्लाई कर दो, और सेकेंड ऑप्शन इज जब ये पॉजिटिव है तब उसको एज इट इज छोड़ दो. लेट्स स्टार्ट बाय डिफाइनिंग फ्यू बेसिक मॉड्यूलस फंक्शन. See, if I want to define mod x, see how will I write? See, in place of fx, I have written -x. So it will be -x if x is negative. And it will be x if x is positive. So this is how I can define fx equal to mod x. See, this is how it is defined. Now let us draw its graph. See what kind of graph it will look like. See, if we follow y equal to x predominantly it is a line like this. But which part of this line I am going to consider for this function? X, see, this is your x equal to 0. So this part signifies x greater than 0. And this part signifies what? X less than 0. So for x greater than equal to 0, I am going to consider the part on the right side. So right side means I will consider only like this. So this is your x-axis, this is your y-axis. Now y equal to x line, that means only this much part we have considered, because this is the part valid for x greater than 0. But for x less than y equal to minus x is to be followed if x is negative. So for x negative, we are getting this particular part. So just put this part over here and it becomes a graph like this. So this is the graph of y equal to mod x, which is a typical V-shaped graph. Now what are the observations that you draw from here? See, this graph is just touching x-axis at origin. Otherwise, it is always above the x-axis. So that is why you will say that this is true for if for all values of x being real. See, this is what we can say. Now, if I try to define, say fx is equal to modulus of x minus 3, if I want to define this. See, in place of fx, what I have written here? I have written x minus 3. So, in the primary definition, you just need to write minus of x minus 3 if x minus 3 is negative. Now, it will be x minus 3 if x minus 3 is positive. See, I am just following the basic definition of modulus of fx. See, mod of f of x is minus of fx if fx is negative, f of x if f of x is positive. Now, x minus 3 negative, what does it mean? X less than 3. This means what? X greater than equal to 3. So, if I write it completely free from modulus, see what is the thing we are going to get? See, it is 3 minus x. If x is less than 3, it will be x minus 3 if x is greater than equal to 3. Now, what kind of graph this function will form? So, if you want to have a look, now y equal to x minus 3 is a straight line like this, y equal to x minus 3. It's going to intersect the x-axis at the point x equal to 3. Now, we need to consider this only for x greater than 3. So, this part. So, that means you just need to consider this part starting from 3. Y equal to 3 minus x is a line like this. Y equal to 3 minus x. So, which part you are going to consider for x less than 3? See, the part which is on the left side of 3. So, this part comes here. So, this is also the V-shaped graph, but the only difference it has with mod x is it has been shifted 3 units. See, the graph of mod x has just shifted 3 units on the right side. So, if I want to draw the graph of x minus 5 mod, so that will look like what? Shifted 5 units on the right side. Mod of x minus 10. Now, let's take another example. If I want to define fx equal to modulus of sin x, where x belongs to 0 to 2 pi. So, if I want to write this, I'll follow the primary definition, and following the primary definition, I'll write sin x. If sin x is greater than equal to 0, minus sin x if sin x is less than 0. Now, how do I make a judgment? Now, let us draw the graph of sin x first. See, sin x has a graph like this, 0, pi, 2 pi. Now, which part of this graph is below the x-axis? See, as you can see, the part 0 to pi is above the x-axis and the part from pi to 2 pi is below the x-axis. So any part that is below the x-axis is what? Negative. Any part which is above the x-axis is what? Positive. So which part of the graph gives you negative? Pi to 2 pi? Which part gives you positive? So x greater than 0 less than equal to pi gives you the positive part. So if I write the intervals in ascending order, see, how do I get it? I'll write it as sin x for x lying between 0 to pi, if x lies between 0 to pi. Whereas for x greater than pi, less than equal to, less than 2 pi, I'll say it is minus sin x. Now what kind of graph this will form? See, no doubt in 0 to pi it follows a graph of sin x. But from pi to 2 pi, see, how will minus sin x look like? See, if I multiply each and every value present on this graph of sin x, अगर sin x के ग्राफ पे हर वैल्यू को माइनस से मल्टीप्लाई किया जाए तो -1 into -1 that will give you what? +1. इसका रिफ्लेक्शन है ये. -12 को -1 से मल्टीप्लाई करेंगे तो हाफ आएगा. यहाँ भी -12 है, इसको मल्टीप्लाई करेंगे तो हाफ आएगा. तो ये सारे इमेजेस इसका जस्ट रिफ्लेक्शन एक्स एक्सिस के ऊपर बन जाएगा. तो किसी भी ग्राफ को माइनस से मल्टीप्लाई करने का मतलब है एक्स एक्सिस के नीचे, एक्स एक्सिस के अबाउट 180 डिग्री रोटेशन कर दे. तो ये पार्ट माइनस साइन एक्स ऐसा बनेगा. So what exactly I have done? Now have a look. See, this was the graph of sin x and this is the graph of y equal to mod sin x. What is the difference between the two? See, all I have done is I have taken reflection of the part of sin x which is below x-axis over the x-axis. And this is another method of finding the definition of modulus of a function. In fact, we will always be using this as a shortcut to find the definition of or defining functions free from modulus. Now let's define modulus of x square minus 1. Now we will follow the graphical method. As I told you just in the previous example, modulus of any function can be obtained by taking mirror image of its original graph about x-axis. So if modulus of x square minus 1 is to be formed, see, y equal to x square minus 1, this is the original graph. It looks like a parabola. Now it intersects the x-axis at minus 1, x-axis at minus 1 and y-axis at 0, minus. Now which part? See, this is your original, that is x square minus 1. Which part of this graph you find it negative? See, this part from minus 1 to 1 is the negative part. So if I take its reflection above x-axis, see, this is how it will form. So if this is the reflection, now the graph of modulus of x square minus 1, in fact, this is how it will look like. Now if this is minus 1, this is 1. Naturally, if this was minus 1, this becomes 0, 1. Now where I have retained the original part, see, these two parts have been retained. So these two will remain the original. Now which part I have taken reflection? This part. यानी मैंने क्या किया? नेगेटिव को पॉजिटिव किया. नेगेटिव को पॉजिटिव कैसे करते हैं? -1 से मल्टीप्लाई करके. तो minus of x square minus 1. So this part will be 1 minus x square. Now you write down the definition. तो modulus of x square minus 1 क्या लिखेंगे? -1 का लेफ्ट में ये किसको फॉलो किया? x square minus 1. ये x less than -1. -1 से 1 के बीच में क्या है? -1 से 1 के बीच में ये 1 minus x square है. or x greater than 1 may get x square minus 1. If this. Let's take another example. If I want to find, say, modulus of log x. Now, modulus of log x as you have seen, this forms a graph like this. Now, which part of this graph is below the x-axis? See, the part from 0 to 1 is below the x-axis. So, if I take the reflection of this part, it should form like this. That means modulus of log x essentially forms a graph something of this type. Now, which part looks as it is? That means the original part. See, the part which is greater than 1 is original. So, I'll write it is log x if x is greater than 1. Now, which part I have taken the reflection? See, the part from 0 to 1, it was negative. And I have made this part positive. So, if I have made this part positive, I'll say if x lies between 0 and 1, I'll write it as minus log x because the negative part has been made positive. I hope you are able to understand. Now, let's define multiple modulus functions. So, if I write, say, modulus of x minus 1 plus modulus of x minus 2, now how do we define it free from modulus sign? Now, what is the point where definition of mod of x minus 1 will change? See, if I want to define mod of x minus 1, we can write it as 1 minus x for x less than 1. For x greater than or equal to 1, this will be defined as x minus 1. Mod of x minus 2 will be defined as 2 minus x for x less than or equal to 2. X greater than 2, it can be written as this much. So, as you can see, the definition of this function changes at 1 and the definition of this function changes at 2. So, the definition of this whole function will change. So, definition will change at 1 and 2. So, if the definition changes both at 1 and 2, so first I will write x less than 1, then I'll write 1 to 2, and finally I'll write x greater than 2. So, modulus of x minus 1, if x is less than 1, it is how much? 1 minus x. So, we write here 1 minus x. And since you are having a plus here, you will put a plus. If there is a minus, you will put a minus. See, whatever operator is there, plus, minus, into, that operator should be replaced here. Now, if x is less than 1, that means it is less than 2 also. So, it will be 2 minus x. So, mod of x minus 2 becomes 2 minus x. For x lying between 1 and 2, see, greater than or equal to 1, mod of x minus 1 is x minus 1. Less than 2, it is how much? 2 minus x. For x greater than 2, it will be how much? X minus 1 plus x minus 2. Why? If x is greater than 2, that means it is greater than 1 also. So, x minus 1 becomes this much. Now, if we simplify this, you get how much? You get 3 minus of 2x if x is smaller than 1. If x is lying between 1 and 2, it will be 1. And for x greater than 2, it will be 2x minus 3. Now, what kind of graph it will form? Let us have a look. Let us say this is your x-axis, this is 1, this is 2. So, if I put x equal to 1 here, 3 minus 2 gives you how much? 1. So, for x equal to 1, this will reach the point 1. So, let us say this is your value 1. Now, it is a straight line having negative slope, so it will look like this. And y-intercept is 3 units, so it will pass from this point. That means it will be tipping like here. From 1 to 2, it is constant at 1. So that means this is how it looks like. It will be constant at this value, that is 1. Now for x greater than 2, if I put 2 here, 2 into 2, 4 minus 3, 1, and it's a straight line increasing like this. So see, this is the kind of graph that it will form. Now what are the things that you observe from here? See, this is the middle interval. So if you are having combination of many modulus functions in form of plus, see, the lowest value will always occur in the middle interval. But remember, this is valid only if you have the plus sign. Now there is a faster way of defining it also. Now the fastest way of defining it is, see, first mark the points where the definition is going to change. If it changes, see, this one's definition will change at 1, this one's definition will change at 2. Now write down the intervals less than 1, 1 to 2, 2 to 3, like this, less than 1, then 1 to 2, and then finally greater than 2. Now in each interval, in less than 1, if I take the values as 0, it is negative, this is negative. So multiply both of them with a minus sign and it becomes what? 1 minus x plus 2 minus x. In between 1 and 2, if I put say 1.5, this is positive but this is negative. So positive means leave it as it is, negative means put a minus and write it. For x greater than 2, if I take 3, 3 minus 1, 3 minus 2, both of them are positive, so you can write them as it is. So we will be using this method in the next problem. Let's take up another problem. Suppose I write fx is equal to say modulus of x minus 1 plus modulus of x minus 2 plus modulus of x minus 3. And suppose I ask you a couple of questions like this. What is the range of this function? Or I ask you, okay, what is the value of say f dash 10? Or I ask you to solve for fx less than equal to 10. Now, multiple questions can be asked based on these functions. See, but the first thing that you have to keep in mind, you should define this function free from modulus. Now tell me, where does the definition of the first function change? The definition of the first function changes at 1, the second function changes at 2, and the third function changes at 3. So if I say x is less than, so let's write down the intervals first. So if I write down the intervals, first interval is x less than 1, then you have 1 to 2, then you have 2 to 3, and finally x greater than 3. See, equality you should never be confused about. You can put the equality left side as well as right side, anywhere you like, or according to the question given. See, for x less than 1, if I take, see, all three of them are negative, say if I put 0, minus 1, minus 2, minus 3. So that means just multiply all of them with a minus sign and write it. Between 1 to 2, see, this is positive, but these two are negative. So it will be x minus 1 plus 2 minus x plus 3 minus x. Now, between 2 and 3, see, this is positive, but this is negative. So, x minus 1 plus x minus 2 plus 3 minus x. For x greater than 3, now all three of them are positive. So, how do I write it? Like this. Now, if you combine now the terms, see, how much do you get? See, this gives you 1 plus 2, 3 plus 3, 6 minus of 3x, provided x is less than 1. See, here this x gets cancelled, so 3 plus 2, 5 minus 1, 4 minus x, if x lies between 1 and 2. If x is greater than 2, less than 3, see what do you get? You get x, and if finally x is greater than equal to 3 or greater than 3, this will be 3x minus 6. Now, see, this is the first step when you have written the value of the individual modulus. Second step, we have defined it. Third step, we are going to draw the graph of this function. So let us mark the points 1, 3 and 5. Now, if I put 1 here, which value you are going to get? 6 minus 3, that is 3. So, let us say 3 is somewhere here. Now, if you put x equal to 1 here, you get 3. So, this will start from 1 comma 3 and end at, if I put 2 here, end at 2. So, this is your value 3. So, let us say 2 is here. So, 3 comma 2. If you put 3 here, that means this ends at 3. So, 3 here, okay, so 1, 2 and 3. Now, 6 minus 3x, that means a line like this, okay. Then 4 minus x, that means a straight line having negative slope like this. Y equal to x, it will be a line like this. And 3x minus 6, that means again a steep line like this. So if this is the kind of graph it forms, what is the lowest value that you can see? See, the lowest value that this function is giving you, the lowest value of y is 2. Otherwise, it always gives you a higher value. So if I ask, okay, what is the range of the function? It will be simply 2 to infinity. And so that's the answer to your first question. If I ask you f dash of 10, now which function is valid for x equal to 10? See, 10 is somewhere here, so this is the function 3x minus 6 which is valid. And for x greater than 3, fx is 3x minus 6. So derivative of 3x minus 6 is equal to 3. Now coming to the third one, if I have to solve x less than equal to 10, see, y equal to 10 is somewhere here. Now, let us solve when it is going to give you 10. So this line represents 3x minus 6. That is less than equal to 10. This means x is less than equal to 16 by 3. So this value is 16 by 3. Similarly, if I solve, now for this point, the 6 minus 3x should be less than equal to 10. This means 3x is greater than equal to minus 4. So x is greater than equal to minus of 4 by 3. So this is minus 4 by 3. Now I want this graph of fx to lie below this line, that is y equal to 10. So this is the set of values, that is minus 4 by 3 to 16 by 3. So x belongs to, so for the third one I will say x belongs to minus of 4 by 3 closed to 16 by 3 closed. So this is the interval where x should lie. Now let's come to properties of modulus first. Now the first basic property is modulus of x. If it is equal to a, that clearly means that x should be either plus or minus a. But this is valid if a is a positive quantity. Now, why? See, parallelly I am drawing the graph of mod x here. Now, if you have y equal to mod x here, let us say this is mod x equal to a. So, this is your line y equal to x and this is your line y equal to minus x. See, x equals to a means this value and minus x equals to a. So, x is equal to minus a. Now, secondly, if I say that modulus of x should be less than a. See, less than a always means below. So, when is this V-shaped graph below this line? See, what are the values of x permissible? See, these are the values of x for which the graph, V-shaped graph, lies below the line mod x equal to a. So, what does it mean? It means that x should be greater than minus a but less than a. Now, if I take a third value, say mod x is greater than a but less than b. Now, where will mod x equal to b lie? mod x equals to b here. So if I talk of this point, it is minus b, and this point is equal to b. Now mod x greater than a means above this line but below this line. So when does this graph lie between these two? That means I am talking about this part and this part of the graph. Now when do you get these two parts? See, the values permissible for x are minus b to minus a और a to b. देखो यही दो वैल्यूज पॉसिबल है. इसका मतलब x माइनस b से माइनस a में लाई करना चाहिए या x a से b में लाई करना चाहिए. Say for example, if I get mod x is greater than 1 but less than 2. So simply I can write x is greater than minus 2 but less than minus 1. Or x is greater than 1 less than 2. But if I have something like this, that mod x is greater than say minus 1 but less than 2. Now what? See, minus 1 lies here. See, left side of this inequality is always 2. So what I should be worried about is only the right side. It should be less than 2. So it is equivalent to an inequality of type 2. So I can write that x should be greater than minus 2, less than 2. So in this case, if the left hand side becomes negative, only the right side is going to be applied, not the left side. Now, mod x equal to a is here and mod x equal to b is here. Now this point is minus b and this point is b. Now if I say mod x is greater than b. Now when do you get the graph of mod x to be above this line mod x equal to b? See, this is the part which is above. Now what are the values of x which give you this? See, either x has to be greater than b or it has to be less than minus b. Now, if I say that modulus of a into b, so that can simply be written as modulus of a into modulus of b. Now, modulus of a by b. Now, this can be written as modulus of a by modulus of b, but if and only if b is not equal to 0. The denominator, if it becomes 0, this entire expression becomes undefined. So that is not possible. Now, interesting thing, if I say modulus of a plus b. Now, this can be written as modulus of a plus modulus of b. Now, but the question arises when? Say for example, if I write modulus of 3 plus 2. See, this is 5 and this can very well be written as modulus of 3 plus modulus of 2. If I write minus 3 and minus 2, now this is minus 5 and that gives you 5. So this is very much equal to modulus of minus 3 plus modulus of minus 2. But if I write like this, now what do you get? 1. Now, is it equal to modulus of 3 plus modulus of minus 2? This is not equal to. So, this equation can hold true. See, if both of them are negative or both of them are positive. That means what? Product of two positive quantities is positive and product of two negative quantities is also positive. So this equation can hold true if and only if a into b is greater than equal to 0. Then only this will hold true. Now if I write modulus of a plus b is equal to modulus of a minus modulus of b. Now when does this hold? So you can see from here itself, see 3 minus 2 is how much? 1. Now, if I put a modulus here and I put a minus sign here. Now see, 3 minus 2 gives you 1 and that is equal. So these two numbers a and b, they need to be opposite in sign. ये दोनों ही अगर opposite sign का होगा तभी ये equation hold कर सकता है, that is a into b less than equal to 0. Now the next property is, see, if you are given modulus of a is greater than equal to modulus of b. Now how do you operate it? See, this can very well be written as a square greater than equal to b square. So this means a square minus b square is greater than equal to 0. So modulus of a greater than modulus of b is very much equivalent to solving this inequality. So whenever you are given an inequality like this, instead of solving it manually, what you should focus on is you should always convert it to an inequality like this. Now let us take some examples. Now suppose I ask you solve modulus of x minus 1 plus modulus of x plus 1 is equal to modulus of 2x. Now if I try to solve this using the normal process, I have to define these three terms free from modulus. Now, but if you mark one common thing, the property which I have told previously, I can write this as x plus 1 plus x minus 1. Now, it comes down to the property modulus of a is modulus of a plus b is equal to modulus of a plus modulus of b. See, if and only if a into b is greater than or equal to 0. So, I can simply write x minus 1 into x plus 1 greater than or equal to 0. Using the sign conventions, if I take the sign of this expression, it will change at minus 1 and 1. So if I put a value of x greater than 1, it is positive, negative and positive. So when do I get it positive? So x belongs to minus infinity to minus 1, union the interval 1 to infinity. So we get a very fast solution using this property. Now let us discuss this question. Now if I try to solve this question by defining it free from modulus, now definitely it is a very tedious process. Now one thing which you should calculate is x square minus 4x plus 3 plus 2x minus 3. See, it is equal to x square minus 2x. So the right side is of the form a plus b. So I will rewrite the equation and I'll write it as x square minus 4x plus 3 plus 2x minus 3. Now this is equal to, see, modulus of 2x minus 3 minus modulus of x square minus 4x plus 3. Now, see, modulus of a plus b is equal to mod a minus of mod b if and only if a into b is less than or equal to 0. So I can write the solution as x square minus 4x plus 3 into 2x minus 3 is less than or equal to 0. So x minus 1 into x minus 3 into 2x minus 3 is less than or equal to 0. Now the sign of this expression is going to change at 1, 3 by 2 and 3. If I put a value of x greater than 3, see, all three terms are positive. So positive, negative, positive, negative. So when is this product negative? So this product is negative in minus infinity to 1, union 3 by 2 to 3. So this is the solution set of this equation. Now let's solve another problem. Modulus of x square minus 1 is less than or equal to modulus of 2x minus 1. Now let's first come to the basic theory behind it. मॉड्यूलस ऑफ a लेस देन इक्वल टू मॉड्यूलस ऑफ b, इसका मतलब हम ऐसे लिख सकते हैं a माइनस बी इंटू ए प्लस बी लेस देन इक्वल टू सी। तो ये इनइक्वालिटी कैसा होगा, दिस प्लस 2x माइनस 1 इंटू x स्क्वायर माइनस 1 माइनस ऑफ 2x माइनस 1 लेस देन इक्वल टू c, and it comes out to be x square plus 2x minus 2 into x square minus 2x less than equal to 0. Now let's first find the roots of this quadratic for factorizing. Minus 2 plus minus root over of 4 plus 4 into 2, 8, 12 by 2. So minus 1 plus minus root 3. Now these are the roots. So x minus minus 1 minus root 3 into x minus minus 1 plus root 3 into x minus 2 less than equal to 0. See, the sign of this expression will change at all these 4 points. So minus of root 3 plus 1, then comes root 3 minus 1, this is positive, so 0 comes in between root 3 minus 1 and then 2. Now if I put a value of x greater than 2, it is positive, negative, positive, negative, positive. So when is it negative? Minus root 3 minus 1 to 0, union root 3 minus 1 to 2. So this is the solution of this particular inequality. To this minus modulus of 2 to the power x minus 1 minus 2 to the power x minus 1 minus. So finally I have an equation of the form fx equal to 0. Now what is the point of change of definition of mod x? X equal to 0. When is this equal to 0? See, 2 to the power x minus 1 equal to 1. So x minus 1 is 0. So x equal to 1. So 0 and 1 are the points where definition will change. So let us take the first interval x less than 0, then x greater than 0 less than 1, and finally x greater than equal to. For x negative, see this as well as this, they are negative. So 2 to the power minus x minus minus plus 2 to the power x minus 1 minus 1 minus. For 0 to 1 this is positive, but this is negative. So it becomes 2 to the power x plus 2 to the power x minus 1 minus 1 minus 2 to the power x minus 1 minus 1. For greater than 1, both of them are positive. So I'll write this as 2 to the power x minus 1 minus. Now if this is my fx, now let us simplify this. So what do you get? See, this term gets cancelled with this one. So 2 to the power x minus 2 for x less than equal to 0. For x greater than 0 less than 1, see these two get cancelled. So 2 to the power x minus 2. For x greater than equal to 1, it is 2 times, sorry, this will be plus 1. So 2 to the power x minus 2 to the power x, 2 into 2 to the power x and minus 1. So this becomes 2 to the power x and it becomes 0. So this comes out to be 0. So as you can see, fx is equal to 0 for all values of x greater than equal to 1. So fx equals to 0 for 1 to infinity, that is by default there. Now let us solve for 2 to the power minus x minus 2 equal to 0. So this is equal to 2 to the power 1. So minus x is 1 means x is minus 1. Now, is this ever equal to 0? See, this can be equal to 0 only when x is equal to 1. Now, x is equal to 1 is not present in this interval. So, in this interval, it cannot be equal to 0. So, the only solution that you get is x belongs to the point minus 1 as well as the interval 1 to infinity. So, this is in fact the solution of this equation.